Golfing is writing code so that it's as short as possible and still does the thing it's supposed to do. In our case, we'll have a hard limit of characters not to exceed, and we'll see how it goes. The idea of this talk came from this site called CodeWars, which a friend introduced me to. And basically, it contains a number of problems that you can solve in various languages. And I found a problem there that I had a lot of fun solving in one July weekend. And I hope to share some of the fun with you today. So what's the problem? It's basically given a chessboard. You need to write a function called isCheck to see whether the white king, which is a solitary white piece on the board, is in check. I'm going to assume that you are familiar with the way pieces move in chess. If not, then, well, you're in for a crash course of some of chess. So you can scan this QR code and try and solve this problem yourself if you want to. There will be spoilers later on, so if you don't want spoilers, take a walk or something. There's some more unfortunate constraints that we need to adhere to, which is that the function must take as arguments the vector of vectors of one character strings. It must return either false or true as the output, no nils, no other generalized booleans. It has to start with a namespace declaration. It has to be called isCheck, and it has to be at most 279 characters length. And by characters, I mean characters as measured by JVM string.length, so not bytes or no full blown Unicode. So I've come up with this meta algorithm for golfing, and it works like this. You start with writing some initial code that works and does the job without worrying too much about how it's going to, how you hit the limit, and then start applying a series of transformations to it that each results in shorter codes. We're chopping characters off, chop, 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 until we arrive at the desired length. So how do we go about checking whether the king is in check? We start with iterating over the fields of the board, filtering out the black pieces, filtering out the one that checks the white king. And if you find them, then we return true, otherwise we return false. So the first thing we're going to do is changing the board representation. So rather than a vector of strings, I prefer to work with this representation of the right, which maps, so we can use it, which maps the coordinates of pieces to the pieces themselves, or spaces in case there's no piece of that coordinates. And I want to do it because it's easier to iterate over the fields, and it also makes me not have to worry about array index out of bounds exceptions or something like this. So I've written this board to map function, which basically does map index over the board twice and returns the result. So going next, we will let's actually implement the chess pieces moving rules. So there's actually two ways a chess piece can move, and I'll call them cast and drops. So cast is when you start at some coordinates where a piece is and start moving along a course, which is given by delta. So for example, horizontally or vertically or diagonally, and so on until you hit something in the space, which is either a piece or nil, which means you've fallen off the board. And then you can check whether that something is a king, and if it is, then bam, the king is in check. So this sample function here verifies whether the rook, the given field, checks the king. And the queen and the bishop move in the same way, or similar way. Now drops are simpler. With drops, you just add the delta once to the coordinates you've started from. Okay, let me go faster and see if you've got a king there. So that's pretty much it. Then we can write a map that maps the type of piece to the function that checks the check. And that's our first solution, and it's too long, but it's a start. So let's try chopping, chop, 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 chop. So first thing comes to mind is stripping waste plate, and you can do it manually. But as it turns out, you can automate it pretty easily with the right CLJ. Hats off to Bog Dude, who is maintaining the right CLJ. Thanks so much. And that gives us this code, which is this long, still too long. So next thing is to refactor a bit. So these custom drop functions are kind of share some similar logic, and we factor that out to a function called attack checks and write cast checks and drop checks in terms of it. And now we can fit all the chess logic on one slide. And see that I no longer have a separate queen checks function because I can rewrite it in terms of SumFn. So we're a bit shorter. Next thing, moving to all the bits and pieces to one function. Because it saves us the hassle of writing def-n all the time, and we no longer need to pass the board everywhere. We're at less than 1,000 now, getting closer. Next up, stripping the names to one letter. Not going to explain this more. We're shorter. Next thing is we introduce one-letter abbreviations from functions in Clojure. So notice we were using map index more than once and Boolean, as we introduce one-letter names for them, and we no longer have to spell out the long names once. Getting closer. Next thing, these long vectors here, we no longer need to spell them in full because we can write a function called R, which takes a one coordinate and rotate it by 90 degrees. And we can now shorten the code to even more. Next thing, we're going to step back and drop the Unicode, and you'll be all ASCII. Unfortunately, it's longer, but now this code has the property of being all ASCII, which will come in useful later. Next trick. We're going to take those long Unicode literals and instead modulo each Unicode value by 14. Why 14? Because it's the smallest number that yields unique values for the chess pieces and the space. So now we get to use the single-digit representation for the chess pieces. We're at 430. Next thing, it's very similar to the previous slide, but we no longer use %1 here. Use just %. Okay, let's do this. And the order of map has changed, which saves us one space. Getting there. Next thing. We get to refactor the function more, so we no longer have use map indexed or iterate or Boolean more than once, and instead we're using shorter code, which gets us down to 400 characters. Are we going to make it? Maybe not, but let's see. Maybe we'll have one extra thing up our sleeve. And if you remember I said characters rather than bytes. So if you represent 2 ASCII characters on one UTF-16 character, then you can write a simple compressor and a corresponding decompressor for the code. And that decompressor, when minified, gets it's only 29 characters in length. So this is our final version of code. Is this short. I made it. And obviously, if we start off with a different algorithm all along, it might have been even shorter without compression, but it was not written by me. That's all I had. Thanks so much.